Hello everybody, welcome back. So today we're going to be talking about pie, and pie is very interesting. So pie is not just what we eat, and it's not just like pie that we do in math. So pie is also an acronym when you get to intermediate counting. So we might have done introduction counting and when Box was doing it, but now we're gonna get a little advanced in this series of intermediate counting and number theory. So PIE stands for principle of so it stands for principle of inclusion or principle of inclusion. God, it's so hard to write vertically for some reason. Exclusion. Okay, so what does that mean? So let's talk about that. So basically it's basically about correcting for overcounting. But yeah, so remember our old friend the Venn diagram. So first of all we have events A and B, right? So when we draw our Venn diagram, this is event A, this whole circle is event A, and this floppy circle is event B. And then we know from our set notation video in algebra 2 that this means the intersection. So in A intersection B means A and B. A and B. And then A union B equals A or B. So now how can we solve for them by using some formula? Well, you might know that, so you might think that A and B is just equal to A plus B. A and B is equal to A plus B. But that's wrong, because we forgot about the section in the middle, right? So first of all, this section is A union B. Or sorry, we don't. Sorry, no, sorry. Messed that up really bad. So this is A intersection B, and I think we were trying to solve for A union or A and or B. A union B. So A union B, my thing is A plus B, right? Because A or B means A or B, so A plus B, right? But that's wrong. That's incorrect. Why is it the case? Well, when you have an event A is equal to well, this area, right? Plus this A intersection B, and B is equal to this area plus the A intersection B. So you're double counting the A intersection B because it's part of A and it's also part of B. So you're counting it twice. So really what we're supposed to do is we have this, and that's equal to the red. So actually, you know what? I'm gonna I'm gonna make this color actually like a wrong color. I'm gonna make this color green. So if we had this color, which is green, then what we really are doing is that A union B is well, you might notice that that's equal to the red plus the green plus the blue, which or the white technically, but let's call this part blue. And then this is a yeah, so the blue is this right now. this is equal to A intersection B. And yeah, that's the answer for this. But A plus B, on the other hand, is equal to the red. So A, which is the red and plus the blue. So the red plus the blue, right? That's A. You see that? And then we also have B. So the B is going to be the green plus the blue. So we're going to have green plus blue. Now you might notice we're double counting this blue. You can see them twice, right there and right there. So to get so now if you subtract one of these, or hold on, yeah, if you were to subtract one of these, then this is A union B. Yeah, there we go. So now we see that A union, or sorry, no, this was A union B. So A union B is equal to A plus B, but minus this blue, and the blue is A intersection B. We said that right here. So we have A plus B minus A intersection B. Okay. So now you get the idea of this overcounting thing, right? Now I just wanted to display the idea in detail of overcounting that A intersection B twice. So this is something important. So I'm gonna square it or rectangle it. Now, what if you had 3 events, A, B, and C? Well, then you'd have to draw more complicated Venn diagram. So this is going to be A. I'm not going to color it in this time. I'm just going to write it with the letter B and C. And then I'm going to use a sparkly thing for yeah. So now we have many things. We have this section, which is A intersection intersection B intersection C. This middle area. Here we have B intersection C. This is A intersection C, and this is A intersection B. Technically minus, so much writing. I'm just gonna say A intersection B intersection C is just equal to big intersection. Yeah, and that's not standard notation, but I'm just gonna do it. So we can rewrite this as big intersection. So that means that now notice that all that I'm doing, like this area over here that I'm redrawing, that's A intersection B. And now this area that I'm drawing, that's A intersection C. And now this that I'm redrawing, that's B intersection C. So these areas aren't B intersection C, A intersection C, and A intersection B, because we have to also add the extra intersection. So if we want to solve for that area, we have to subtract the intersection. So we have A intersection B minus intersection, minus the big intersection, minus this intersection, minus this intersection. There we go. Because this total area is B intersection C, I'm just re-saying it. So this area is B intersection C minus this intersection. Okay, so if we wanted to solve for so now we want to solve for A union B union C. What's that equal to? Again, it's not A plus B plus C, but we can use that idea as a beginning like we did last time. So we can say that A plus B plus C is equal to, that's going to be equal to, it's going to be equal to A union B union C, right? But we're going to have the extra, wait, let me think. So, yeah, so A plus B plus C is going to be A plus B plus C. So we're going to have, 2 times A intersection B, right? We're gonna have two of them. We're also gonna have two of the A intersections C, and we're gonna of course have two of the B intersections C. But then the middle is gonna be counted 3 times, so we're gonna have 3 times big intersection. So now, what we have to do is if you're solving for this, we have to subtract all of that. So we say that that's equal to A plus B plus C minus 2 times, you can factor out a 2 out of these, and we get 2 times A intersection B plus B intersection C, that's a triangle, plus A intersection C. And that minus the 3 times big intersection. Now big intersection is not standard notation, so I might as well rewrite it now because we have unlimited space. So remember that is A intersection B intersection C, which means what's included in all of them. So I can rewrite that here too. Okay. Yeah. I want to just explain this a little. So A plus B plus C. So notice that A plus B double counts this area. Wait, is this right? Hold on. Yeah, so A plus B plus C minus 2 intersection. Wait, oh, I think I messed this up. Okay, so you have A plus B plus C minus now. Yeah, so you have 2 intersection. So what this is gonna get you, I'm not gonna write equal. So what this is gonna get you to, this is gonna get you to A plus B plus C minus 2. Okay, so then A plus B plus C. So we subtract oh, I think we have to subtract this big union, right? And then if you subtract the big union from all of them, we get minus 3, so minus 6. And then we have to add 3, I think. So, how do we do this? Huh. Okay, so A plus B is equal to A. Huh. This is really weird. A. Okay, that, right? Plus, right? That's just based on our old equation. And then so now we can redo that. So now we have P plus C equals B C plus B this thing. A plus C is equal to A union C plus A intersection C. If we add them all up, we get. I'm so confused. How do we do principle of inclusion and exclusion for A, B, and C? we get A plus B plus C, right? Okay, minus 2A intersection B okay, I'm just gonna write it out like this. So obviously this is used once, this is used twice, this is used 3 times. Or no, this is used 6 times because there's also the A intersection B, B intersection C, and A intersection C. And this part is used 2 times. And that's the same for all of them. So okay, so then that would just be A plus B plus C minus, yeah, I messed this up, okay. So minus this, just once, right? And then we also have to minus B this, right? Minus this. There we go. And then, so yeah, we have 3 times this. And then we also have to do, minus 5. Wait, is it 5 times? I'm so confused. So it's included 3 times, right? Technically it's 3 because you don't have to count those ones. So minus just 3 maybe? Yeah, I think that's it. Yeah. So yeah, I think that should be it. Not this. This is wrong. Give me a sec while I check that. Okay, so I had a chance to look over it, and now this is wrong. I got everything else right. Really happy about that. But it's just plus that. There's no constant in front of it, anything like that. Let's look at y. So when we add minus 3 times, or wrong, this is the wrong way. Then, yeah, we didn't account for these. I counted them for the first time, but then I didn't for some reason. So, yeah, when we do, this, then we're including this part, but then this whole part we're actually supposed to be doing. So we'd be, having to, so this would be removing this thing so many times that we need to add it so that it works out. So sorry about the confusion, but this is the formula. Oh wait, hold on, I didn't really, hold on. So I'm just gonna like put it up here. This is equal to A plus B plus C minus A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C. Okay. Now I'm gonna give you a challenge. First of all, these two are the main ones, and you're gonna have to really need. But I'm gonna give you a big challenge. I want you to do it for four. For four sets A, B, C, and D. That would be a lot harder because there's gonna be many more combinations, and it's harder to visualize. So you might as well think about it in your head. And please respond in the comments, not comments. But yeah, thank you so much for watching. And I'll see you guys in the next one. Goodbye.